All right, so today we're going deep into satellite imagery and AI. You know how we can tell a park from a parking lot from space? Well, researchers are using AI to identify specific crops from orbit.
Yeah, it's pretty remarkable.
Yeah.
The level of detail we can extract from satellite data is changing things like agriculture. We're diving into this paper from the Quirkus Software Engineering Group in Spain, and they're tackling a really interesting challenge.
Yeah, the paper mentioned agricultural subsidies. How does knowing what farmers are growing from space help with that?
Well, think of the traditional method. Someone has to physically verify what's planted, time-consuming, expensive, and prone to errors. With this new technology, subsidy agencies could monitor crops from space, ensuring that funds are allocated accurately and fairly.
Okay, that makes sense. But I'm picturing someone in space with a giant magnifying glass looking at tiny fields. How does AI actually tell corn from sunflowers?
It's not about visually recognizing the plants, it's much more sophisticated. This research leverages the fact that different plants reflect light differently, especially in wavelengths we can't see.
Oh, so each plant has a unique light signature.
Exactly. And the Sentinel-2 satellite the researchers use can capture images in 12 different wavelengths. That's way more information than a standard color photo.
That's cool. But I imagine those satellite images are massive. How much data are we talking about?
One image can have over 120 million pixels. And the researchers used multiple images for each location over years. It's a treasure trove of data, but a computational challenge. They had to get creative.
So they didn't just throw the data at the AI and hope for the best.
No, they came up with synthetic images. Instead of the entire image, they focused on individual pixels.
Wait, they made pictures out of pixels.
In a way, yes. They took the data for a single pixel across all 12 wavelengths and 21 time points, representing different times of year, and turned it into a tiny 12 by 21 pixel image.
Whoa, so each picture represents the life cycle of that spot on the ground.
Precisely. And because they used data from the Spanish subsidy agency, they knew what was planted where. So they labeled each synthetic image with the correct crop type.
So they're training the AI to recognize crops based on their light signature over time. It's like giving AI a superpower.
You could say that. They used 9.7 million synthetic images for training.
Yeah.
That's how they got such impressive results.
Okay, I have to know. How accurate was the AI at identifying the crops?
They tested it on data from 2020, a year the AI had never seen before. For some crops like rice, corn, and tomatoes, the accuracy was 97%.
97%. That's incredible. Were all the crops that easy to identify?
Some were more challenging. Asparagus, for example, only had 42% accuracy. But even for crops like sunflowers, which came in at 70%, still pretty remarkable when you consider what they're doing.
So some plants are trickier to identify, even with AI, but overall, it sounds like a huge step forward.
Absolutely. And what's really fascinating is that when you average the synthetic images for each crop, you can actually see the spectral signature, the unique way each crop reflects light in those averaged
Okay,
images.
so each crop has a visual fingerprint of light, and this AI can see it. That's amazing.
It is. And this is just the beginning. Think about the possibilities. The future is full of possibilities, and AI will be a huge part of it. It's up to us to use it wisely for everyone.
Thanks for joining us on the deep dive. Until next time, keep exploring, keep learning, and keep asking questions.